Hello class, welcome to another lesson. Today's learning goals are I can multiply and divide numbers in scientific notation, and I can solve real-world problems involving the calculation of numbers in different forms. So let's go ahead and get started. So we're going to be multiplying and dividing numbers in scientific notations. To multiply or divide in scientific notation, we need to multiply or divide the coefficients, multiply or divide the bases in base 10 factors. That's step 2. In step 3, rewrite the note in scientific notation if necessary. Okay? So 3 steps, and I'm going to try to do those 3 steps in different colors so that we can see what we are doing. Okay, so let's take a look at this first one. An Olympic-sized swimming pool is about 5 times 10 to the 1 meters long and 2.5 times 10 to 1 meters wide. Find the approximate area of the water's surface. Give your answer in scientific notation. Now, so we have a swimming pool that is this long and this wide. We're trying to find the area, and if you remember from previous years, to find the area of a rectangle, you have to multiply length times width. So, we're going to multiply these two together. So, the first part is to multiply the coefficients. So we're going to do, actually let me show it this way. 5 times 10 to the 1, okay, that's the length. We're going to multiply that by 2.5 times 10 to the 1 as well. Okay, now we know that multiplication is commutative, so I can rewrite this as 5 times 10, 5 times 2.5. Those are the two coefficients, times 10 to the 1 times 10 to the 1. Now, these are the coefficients right here, 5 and 2.5, so I'm going to multiply them together, and we get 12.5. Then I'm going to multiply the bases together, 10 to the 1 times 10 to the 1, we add the exponents, so we get 10 to the second. Now, so those are the first 2 steps. We have multiplied the coefficients, we have multiplied the bases together. Finally, what we're going to do now is we are going to rewrite this in scientific notation. This is too big by 10, so we need to move it back once, which means we are going to divide our coefficient by 10. And we're going to multiply our base 10 factor by 10. So therefore, we get 1.25 times 10 to the third square, because we're doing square. That's how you spell it. Nope, that's not how you spell it at all. It's just Q-U-A-R-E, square meters, because this is area, so we're going to have square meters. Okay. Let's take a look at the next one. The length of an Aztec stadium in Mexico is 1.05 times 10 to the second meters long and 6.8 times 10 to the 1 meters wide. Find the area of the stadium. Give you your answer in scientific notation. Again, we're going to multiply because we're finding areas, and we have the length and the width. So we have 1.05 times 10 to the second times 6.8 times 10 to the first. I'm going to rewrite this so the coefficients are next to each other. 1.05 times 6.8. And then bases are going to be next to each other. 10 to the second times 10 to the first, because we can, since multiplication is commutative. Multiplying the bases together. 1.05 times 6.8 is going to be 7.14. Then multiplying the bases together, 10 to the second times 10 to the first becomes 10 to the third. 10 to the third. Okay, so again, these are the coefficients. We multiply them together, and these are the bases, and we multiplied them together. And luckily for us, this is already in scientific notation, so we don't need to adjust it and do step 3. So we simply put down our units, square meters. Okay. The next one. In the 19th century, the walls of Brussels was the largest building ever built. Had a base area of about 1.6 times 10 to the second meters by 11.5 times 10 to the second. Find the approximate area of the building. Give your answer in scientific notation. Okay. Again, this is find the area. Okay. So again, we have the length and the width. So we're going to multiply them, 1.6. I'm just going to put the bases next to each other. 1.6 times 1.5 times 10 to the second, putting the bases together, or the base 10s together, times 10 to the second. Okay. Now we will multiply the coefficient, 1.6 times 1.5. That is going to get us 1.6 times 1.5, 2.4. Then we're going to multiply the base 10s together. 10 to the second times 10 to the second is 10 to the fourth. It's already a scientific notation, so we don't need to change it. And again, we have square meters. Go ahead and try this one on your own. Again, this is a find the area. So we're going to again multiply. So we have 1.02 times 8.02. Excuse me. And then we're going to multiply the base 10s together. And 1.02 times 8.02 is 8.1804. And then we're going to multiply our base 10s together. 10 to the third times 10 to the second is going to be times 10 to the fifth, because we add our exponents. This is again in scientific notation. Hurrah! So we don't need to adjust it. So we simply put the square meters, since we're doing area, as our unit. Okay. So, some of the smaller planets in the solar system are Mercury and Mars. The planet Mercury has an approximate mass of 3.3 times 10 to the third. Mars has a mass of about 6.4 times 10 to the 23rd kilograms. How many times greater is the mass of Mars than the mass of Mercury? Give your answer scientific notation, round your coefficient to the nearest tenth. So, what we have here is something that is bigger than the other. So Mars is bigger than Mercury. We're asked to find how many times greater is the mass of Mars than the mass of Mercury. So we know that Mars is going to be bigger. So we're going to put the bigger one on top. And you can see that their exponents are the same, but the Mars one has a greater coefficient. So I'm going to write this with the Mars on top. So 6.4 times 10 to the 23rd divided by 3.3 times 10 to the 23rd. Okay. Which means that we can divide the coefficients. So 6.4 divided by 3.3, when rounded to the 10th place, is 1. Oops. Hello. Is 1. Nope. Oh no! Come on. Work. 1.9. And then we're going to divide 10 to the 23rd by 10 to the 23rd, which gets us 10 to the 0. Because we're going to write in scientific notation. So it is 1.9 times 10 to the 0 times bigger, and we don't need to change it because it is already in scientific notation. The next one. The sun's diameter is about 3.3 times 10 to the 23rd kilograms. The moon's diameter is approximately 3.5 times 10 to the 3rd kilometers. How many times greater is the diameter of the sun than the diameter of the moon? Well, let's start with this. Here's an error. This is supposed to say kilometers, not kilograms. That doesn't make any sense. Kilometers. Ooh, that doesn't make sense. So, again, is how many times greater is the diameter of the sun? The diameter of the sun is greater, so we're going to put that at the top and do 3.3 times 10 to the 23rd over 3.5 times 10 to the third. It says round your coefficient to the nearest tenth. So, what we're going to do is from here, we're going to do the division. And 3.3 divided by 3.5 is 0.943. And then 10 to the third divided by 10 to the 20 to the third divided by 10 to the third is times 10. Oops, I said I'd do it in different colors. Aha. Is 10 to the 20th since we're subtracting. This is not in scientific notation. So we're going to make it in scientific notation by multiplying our coefficient by 10 and dividing our base 10 factor by 10, which gets us 9.43 times 10 to the 19th. Now, it did say that we were to round our final answer, okay, to the 10th place. So our final answer is 9.4 times 10 to the 19th times bigger. Okay. Now notice in the last one that when it said round to the 10th place, I simply just wrote 1.9. Okay. That's because I knew that this is going to already be in scientific notation, so I can round it to the 9th place. Here, I put down some extra digits because I knew that this is not going to give us a coefficient that gets us something that gets us into scientific notation. So I get some extra digits so that I can round once I get my final answer. Okay, so make sure that if it's not written in scientific notation, you write some, the coefficient is not good for scientific notation, you write some extra digits so that you can round your final answer at the end. Okay. Go ahead and try the last two on your own. Here, what we're going to do is find out how many times bigger is the Jean-Luc Lagardère than the NASA Vehicle Assembly Building. Okay, so what we're going to do is take the value right here and divide it by this value right here. So we got 5. Oops, let's use a different color, like red. 5.6 times 10 to the 6th over 3.7 times 10 to the 6th. We're going to divide and divide our coefficients and get 1.5, and I know that's going to be a perfectly fine coefficient for scientific notation, so I'm just going to leave it as 1.5 and not give the extra digits at the end. And then 10 to the 6th divided by 10 to the 6th is going to be 10 to the 0. And that's already in scientific notation, so we don't have to do anything about it. So we just write our units times bigger. Our last example. So then we're going to find how many Earths can fit inside Jupiter. So Jupiter is bigger, so we're going to put that at the top. Different color, like red. 1.43 times 10 to the 15th divided by, that's Jupiter, and we're going to divide by Earth because Earth is smaller, times 10 to the 12th, which means that we are going to divide our coefficients. 1.43 divided by 1.08 is 1. Ooh, that's not the color I wanted. Blue is the color I wanted. 1.3, and I don't need to go any further because this is a perfectly fine coefficient, times 10 to the 15 minus 12 is third. So 1.3 times 10 to the third is the number of Earths that can fit into Jupiter. Go ahead and like and subscribe. Thank you for watching.